Okay, hi everybody. Happy Friday. I'm out down in the cyber wing today taking meetings all day, so just want to make sure that we understand how to solve radical equations. And so this is page 2 of your notes that you received from the sub, and make sure you get a copy of that, and then go ahead and jump into this. So when we're talking about radical equations, we're talking about something that has a square root or a cubed root or a fourth root or anything like that inside of it. And so we're going to walk through the process, excuse me, and then we're going to do examples 1, 2, and 3. So anytime we want to solve a radical equation, like I said, something that has a square root, a cube root, a fourth root, first thing we want to do is we want to get that radical all alone. So technically what we're going to do is we're going to isolate. So isolate the radical on one side of the equation. So isolate the radical on one side of the equation. And really when we talk about the word isolate, we're talking about getting it alone. Alright, so if we have anything that's multiplied on, added or subtracted, that's outside of our square root sign or our radical sign, we got to get rid of it. Alright, next step. We have to eliminate the radical sign, so we need to raise each side to a power to eliminate the radical. So raise each side to a power to eliminate the radical. Alright, so that's our second step. The third step is we just want to solve it now. So solve using algebra. But there's one other thing we got to do anytime we have a radical, and we have to check for what's called extraneous solutions. So check for extraneous, E-X-T-R-A-N-E-O-U-S. I think that's how you spell it. Extraneous solutions. Well, what the heck is an extraneous solution? Basically, sometimes when you raise things to powers, you introduce answers that are not valid. So they're fake. And I know that's really weird, but we call those fake answers extraneous solutions. So let's write this down. Raising each side of an equation. So raising each side of equation to a power may introduce solutions that are not valid. So essentially what we got to do, we got to make sure we check our answers and make sure that they fit within our problem. Okay, so let's jump into these examples right here. Let's take a look at this example on the left. 2 times the square root of x plus 1 equals 4. All right, first thing we got to do, step 1, isolate the radical on each side of the equation. Get it all alone. So you can see how I've got a 2 times all of this. So the first thing I want to do is divide both sides by 2. Okay? When you divide the left-hand side by 2, those two things cancel each other out. The 2 times and the divide by 2 cancel. And so I'm left with the square root of x plus 1 on the left. On the right, real simple, 4 divided by 2, whoops, is 2. Alright, so that's the first thing we want to do. The next thing we want to do is we want to square both sides. So, let me change my pen colors here just a moment. I'm in my chair, I got to get up and move. Alright, the next step that we want to do, as I said, excuse me, is we want to square both sides. So we square this side. And we square that side right there. On the left-hand side, when you square a square root, they cancel each other out. So this is, we're left with x plus 1 on the left-hand side. On the right-hand side, we are left with 4. And now it's a real simple process to solve. We take away 1 from both sides, and we have x equals 3 as a potential answer. You have to check. All right? So my last step here is to check to make sure 3 works. And so I take 3 and I plug it back up into my original formula, and I have 2 times the square root of 3 plus 1, substituting 3 in for x, and basically I'm checking to see if that equals 4. And this comes out to be 2 times the square root of 4, and 2 times the square root of 4 really is 2 times 2, which in fact equals 4. So it checks out. So that means 3 gives me an answer of 4, plugging 3 right here. So that means that that's a valid answer. So our answer is going to be x equals 3. Okay? Same process if we are doing cube roots. So you can see we've got the cube root of 2x minus 9 minus 1. This minus 1 is on the outside, so I got to isolate. And I isolate the radical by adding 1 to both sides. I get the cube root of 2x minus 9 equals 3. And now, since this is a cube root, my next step is to cube both sides, because cube root and cube are opposite operations. And when I cube this side, I get 2x minus 9, and when I cube this side, I get 27. And now we do our algebra. So add 9. And I get 2x equals, that's 36. And then I divide out by 2 and do that on both sides, and I get x equals 18. You gotta check it. All right. So cube root of 2 times 18 minus 9, and then outside we got a minus 1. And we are checking to see if that equals 2. Well, 2 times 18 is 36. So, cube root, sorry, forgot about that. All right, so 2 times 18 is 36, minus 9 is 27. So, cube root of 27 minus 1. And we're checking to see if that equals 2. Cube root of 27 is 3. 3 minus 1 equals 2. It checks, so that means 18 is a valid answer. Okay? If you did not get these two sides to be equal, you would throw that answer out. And we'll probably run into an example of that before we go. All right, example 2. Example 2 is a real-life problem. So here's what we got. We got a hurricane, the mean sustained wind velocity v. It can be modeled by v of p equals 6.3 times the square root of 1013 minus p, where p is the air pressure in what they call millibars. I don't know what that is, but it sounds good, at the center of the hurricane. Estimate the air pressure, okay, which is p, at the center of the hurricane when the mean sustained wind velocity is 54.5 meters per second. So the mean sustained wind velocity is our v of p. So basically they're saying v of p equals 54.5. And they want you to figure out what p is, knowing that v of p also equals 6.3 times the square root of 1013 minus p. So essentially what we need to do is we need to take those two equations and put them equal to each other because they're both equal to v of p. So let's do that. 54.5 equals 6.3 times the square root of 1013 minus p. And to solve that, the first thing we're going to do is divide out our 6.3. Writing it a little differently this time, no big deal. All right. All right, so 54.5 divided by 6.3 is 8.6507. Let's take it out a few decimal places. And that equals the square root of 1013 minus p. Our next step is to square both sides. And I'll come up here so I have more room to write. And when I square the 8.6507, I get 74.8346. And when I square root this side down here, the square root of 1013 minus p, I just get 1013 minus p. We got to get rid of the 1013. So when I take it away, take away 1013 and take away 1013. 74 minus 1013 is negative 938.1654. And now be careful here. That equals negative p. Okay, negative p. And so obviously if negative p equals negative 938.1654, positive 938.1654 equals positive p. And there is our p value, which is air pressure in millibars. All right, so that's example 2. Finally, example 3. This is going to be a fun one. All right, solving an equation with an extraneous solution. So, first things first, if we go back to our process from the previous page, we want to isolate this square root sign, and it's already isolated. So, we're good there. All right, now, since it's isolated, we want to get rid of this square root sign, and we do that by squaring both sides. Now, when we square this side, where we have the square root, they cancel each other out, and we get 7x plus 15. On the left-hand side, though, because we have this quantity squared, we got to do some magic squares. Because really this is x plus 1 and x plus 1. And so x times x is x squared. This is 1x, 1x, and 1. So that means that this left-hand side, when I FOIL this out, is x squared plus 2x plus 1. Woo, good times. All right, so we got that. Now, we need to solve this. In order to solve this, we got to get it equal to 0 first. So I'm going to subtract off 7x and subtract off 15. Since they're both currently positive here, I can subtract them there. Do that over here also. And we get x squared minus 5x minus 14 equals 0. We want to solve that quadratic, and we've got lots of different ways to solve the quadratic. We can graph it, we can factor it, we can use the quadratic formula, which is actually up on the board right now for another class. I am choosing to factor this, so make a little note here, solve by factoring. If you want, you can graph it. Okay, if you choose to graph it, you're looking for the x-intercepts. But I love to factor, so here we go. So factor x, I got to put a 14 up there, negative 14. I got to put a negative 5 down there. Two numbers that multiply to get negative 14 and add up to get negative 5 are negative 7 Come on in, I'm just doing a lesson for tomorrow. -7 and 2. So that means that this bad boy is going to factor into x minus 7 and x plus 2, and that equals 0. Now to solve that, come up here. To solve that, we take each of those factors, stuff we've done before many times, and we take each of those factors and put it equal to 0. And that means that we have a factor of x equals 7 and x equals -2. Now, we have to check those. So, we got to take this x equals 7 and check it. Which means I got to plug it back into this original equation. 7 plus 1 equals the square root of 7 times 7 plus 15. So we're checking this one. And we get 8. Here we get 7 plus 7, which is 49, plus 15, which is 64. And you can see that that one works. So that means that this is a good answer. We got to do the same thing now with the -2. Sorry, this is a little all over the place, but you should be used to it by now. Okay, so I got -2 plus 1 equals square root of 7 times -2 plus 15. -2 plus 1 is -1. This is 7 times 2 is -14. Sorry, 7 times -2. Plus 15, square root of 1. We get -1 equals 1. That is bad. No. So what does that mean? That means that -2 is an extraneous solution, and that means it is not a valid answer. So we would cross that one out. So that means our only answer is x equals 7. So we only have one answer there on that one. All right, that's all I got. Enjoy the PEP assembly, and we'll see you on Monday. Of course, unless I win the lottery. Take care.